So hi, my name is McLean. This is Mike. We're with SolidFire, and we're here to talk to you about storage plugins for the new framework, the architecture that Edison discussed here. Mike's been a developer with SolidFire that is 100% dedicated towards CloudStack, and I work with our technology integrations. So just before we dive into the plugin, I wanted to give you an overview of how we look at the opportunity for CloudStack from a storage lens. So what is the opportunity? For us, it's a very simple question. We believe that there is a gap in the marketplace for high performance applications that are high value, high margin value to the business. Currently, there's quite a bit of success in the marketplace with applications running in dev and test, backup and archive, but there really is a gap when it comes to high performance business production level applications. And so why do we think this? Well, we used history as a way to guide us here. When you take a look at VMware, the initial years of VMware, you see that they had a heck of a growth rate there. And the key here is, though, is understanding that these are the initial years during their test dev use case. So this, initially, as we all know, that VMware was much more successful early on in a test dev use case. It took them a while to get to production. And when you take a look at it from the cloud computing lens and you shift over, you see a very similar growth rate. Now here we used, we took a look at Amazon and the initial years and initial growth of Amazon, and you see that it's a very similar growth rate. But the key here is that it's still a test dev use case. Now, when you zero out the time and you overlay these curves, you can see that they're basically the same trajectory there. And so, unlike VMware, cloud computing hasn't had that next stage of going into production, but what I want to do is show you how the story finished out for VMware. So adding on the next 5 to 6 years, again the growth rate continued up and to the right. There was a dip. That was economic times, tough times there, but still overall a very successful growth rate. And you want to look at this from the first 6 years to the last 6 years on this. There was a transition from test dev to not just test dev, but adding on production environments. So bringing this whole story together, I think you can see that the story is still to be written from a cloud computing perspective, but we're on a good track early on to have a very similar process, a very similar path. The key will be having the innovation necessary to transition from test dev to adding in production level applications, production grade. So just kind of tell you how when we talk about innovation, we really think that this gap is held back by innovation in storage systems. It's held back by innovation in the orchestration platforms, hypervisors. It's going to take a collective level of innovation around availability, performance, quality of service, scalability, and automation to really tackle this. And so when you think about this from a CloudStack perspective, what does it mean to CloudStack? Well, storage is a significant pain point in a cloud deployment, in cloud environments. This is because it's very difficult to deliver consistent, repeatable performance to tens, hundreds, or thousands of applications at the same time in parallel. Storage systems just aren't designed for multi-tenancy. We believe that through development efforts, not only from our perspective as a storage system provider, but development efforts in CloudStack, we can really bridge that gap and take it from test dev to mission or business critical applications in the cloud marketplace. So I'm going to hand it over to Mike. We're going to now go through the plugin that we've been working on and how it relates to the work that Edison's been doing on the storage framework.
Thanks, McLean. All right, so what I wanted to start off with today was just to show you kind of where CloudStack is prior to 4.2 and where it's potentially going with 4.2. On the left-hand side here, we kind of see the traditional storage system, which is the way that CloudStack was initially developed. In CloudStack today, what you might do, what's common is to go in, I'm going to talk in terms of SANs, but just storage in general. You might go and provision a really large volume on your SAN and then go and expose that to CloudStack as primary storage. And then as you can see on the left-hand side there, with that primary storage, you're going to run a whole bunch of VMs and data disks off of that particular volume. That's fine for existing storage systems. What we'd like to do is take it a step further where we actually have more of a one-to-one mapping between the SAN volume and a VM, or the SAN volume and a data disk. And why might we want to do that? A great reason would be for quality of service. So on the left-hand side here, you don't necessarily know what kind of performance to expect out of that SAN volume. And if you're running multiple VMs and data disks off of the same SAN volume, you especially don't know what to expect from any individual VM or data disk. In our future vision here, what we see is, as an example with SolidFire, being able to guarantee a certain number of IOPS to a specific volume on the SAN, and then mapping a single VM to that volume or a single data disk to that volume allows you to pass on services to customers. Say you have an application that needs 1,000 IOPS for its root disk, 2,000 IOPS for its data disk. Well, you can do that in this new model if you have this one-to-one mapping. So that kind of takes us into the use cases for a CloudStack plugin. The first one is kind of what I talked about just a moment ago, that initially CloudStack wasn't designed around such granular use of volumes from the storage system. It was designed around providing a really big amount of storage at a time to CloudStack. So obviously for the reasons I just mentioned, we'd like to make that a little bit more fine-grained going forward. The bottom part of that is just talking about specifically in regards to SolidFire, but doesn't have to be SolidFire specifically. There are other uses for this. We'd like to see features such as minimum, maximum burst IOPS added into CloudStack so cloud service providers can pass on those benefits to their customers as well. So what are my specific needs as a software developer to make this happen? The first point there is I need the ability to be able to defer creation of that volume on the SAN until the last possible minute. The moment the customer decides to pick a particular compute offering or a particular disk offering, at that moment is when I know the size of the root volume, I know the size of the data volume, and I can go off to the SAN and create that. So I need a little bit more dynamic abilities to be able to create those volumes on the SAN. I'd still, as in that second paragraph there, still want the CloudStack administrator to be able to control primary storage. We don't want to pass that on to the user. But instead of basing primary storage exclusively on pre-existing volumes, we'd like the ability to have the CloudStack administrator select a plugin to base primary storage on, and then that plugin can be utilized going forward to create volumes and delete volumes as needed. The third point here is we don't want any requirement for the cloud service provider to have to write orchestration logic, such as what CloudStack does really well, to provide these abilities. So prior to 4.2, it is actually possible to do what we're talking about here, but you have to actually write a whole bunch of code yourself to talk to the SAN, create the volume, go talk to the hypervisor, if it's Zen server, create a storage repository, then go talk to CloudStack, make primary storage based on that storage repository. There's a whole bunch of logic involved in that, and we don't really want to have cloud service providers writing that kind of logic into their business portals. So how do you actually make a plugin in CloudStack? There's three components to this: the provider, the lifecycle, and the driver. The provider has all of the general kind of purpose logic, like what's the name of this plugin? Can you provide me with the lifecycle object that controls when a storage system is added and removed from CloudStack? And the driver is related to actually creating and deleting volumes dynamically on the storage system. That bottom part is more a bit of configuration. Since your plugin is actually another Maven project, what this is showing here is if you're in the root directory of the management server, if you go into the client directory, there's a project object model file that you need to add a dependency to point to your plugin so the management server knows to load that jar. All right, so diving a little bit into the provider, the first requirement is that it has to implement the primary Datastore Provider interface, and we'll get into that in a little bit more detail in a second. The second thing here is it just talks about some of the basics. Part of the interface, it provides a way of saying the name of the plugin and some of the other related features like the lifecycle, the driver. The third bullet point there is in reference to a Spring framework related concept. You need to actually go into this application context file and add a line which describes your plugin, and we'll get to that in a little bit as well. And then just for clarity's sake here, that bottom line is just saying that this is true about providers, but it's also true about life cycles and driver objects. If I have, let's just use SolidFire as an example, I might have multiple SolidFire SANs. Regardless of how many SolidFire SANs you have, you would just have a single SolidFire plugin, which would amount to a single instance of the provider class, single instance of the lifecycle object, and a single instance of the driver object. So just kind of wanted to clarify that. All right, so I noticed nobody else went to code, but might as well go there. We talked about an interface that we had to implement before, the primary Datastore Provider. So what you can see here is actually, by itself, it doesn't look that exciting. It really just extends another interface. It's possible at some point in the future, primary storage might actually have some specific methods that you need to implement that are different than secondary storage. But at the moment, there's nothing specific in the provider case. So we just extend this Datastore Provider interface, and it has all of the methods that the provider class needs to implement. So what you can see here is just some of the basics, the Datastore lifecycle, the driver itself. If you're interested in events when a host is added or removed from CloudStack, if your plugin needs to know about those kind of events, you can register a listener here as well. Basic get name method. So in my case, I might just return SolidFire. And configuration is your opportunity. We get into this method in a second, but that's your opportunity to actually set up your provider. And then the bottom method is a way of saying whether you're a primary storage provider, secondary storage provider, maybe you're both. Returns just a set of data. In my case, I'm just primary. All right, so a little bit of implementation code here. This isn't the whole class, but just kind of gives you a flavor for what I was talking about. You can see that the SolidFire primary data store provider class implements the primary data store provider interface. Got a couple member variables. Let's look at some of the overridden methods. So the getName method just returns that provider name, which is just SolidFire. So that's the way I would identify this plugin when I invoke the API to actually make use of it when I want to create primary storage. So when I want to create a primary storage based on SolidFire, for example, I would pass in SolidFire, and it would recognize it by querying all of the existing providers and hopefully finding one that says it's SolidFire. The next one is the data store lifecycle. This is just going to return a pointer to my data store lifecycle, which was actually instantiated in that configure method. So the configure method, like I was mentioning before, that's just your opportunity to actually set up your plugin. In this case, it's using this inject logic, which is related to Spring Framework. It's going to make an instance of the class that's defined there, set some properties, return a pointer to that, and then just kind of store it for later use. And a little bit in terms of just configuration for this provider, since this is kind of the interface to the outside world for the plugin, it requires a little bit of configuration in this application context XML in file. So it's off the root again. It's in the client Tomcat conf directory. Kind of skipping to the bottom here, just to give you an example. It's just basically one line that you need to add into this application context file. What I did was I actually found this classical primary data store provider line in the file. And that's the, by default, CloudStack has a single storage plugin, and that handles the logic you're familiar with from pre-4.2 days. So that's a plugin by itself. I just found this in the application context file, copy, pasted, and then I filled in the details related to my plugin. So the class, you can see it's the SolidFire one. The ID field can really be, in this case, anything you want it to be, since we don't access the bean through the ID. It's just a way for, in this case, for Spring Framework to keep track of the information on the beans. Let's see. All right. So moving on to the life cycle. So remember, we had the provider first, then we have the life cycle, then we have the driver. So the life cycle, similarly, it has to implement a special interface. This is the primary data store lifecycle interface, and we'll get into the details on that one in a second. This handles the creation and deletion of a storage system to CloudStack. So if I want to add a SolidFire SAN into CloudStack to be used, this controls the addition of that SAN. Eventually, when we phase out that SAN, it'll control the deletion of it from CloudStack. So not dealing with specific volumes on the SAN, but rather the SAN itself, or the storage system to be more general. Let's see here. So basically, there's one method I kind of wanted to point out here. It's the initialize method. What this will do is actually add a row into the cloud storage pool table that represents the newly added storage system. And I believe we'll get into that one in just a second. All right, more code. Good. So same kind of thing as the last thing we looked at. You've got the primary data store lifecycle interface extending the data store lifecycle interface. The primary one at this point in time doesn't have any methods that are specific to primary storage, so it just inherits all of the methods that you have to implement from the data store lifecycle interface. Some of the interesting ones would be the initialize method that I was just referring to. If you're cluster-wide storage, you might want to do something when you attach to a cluster. If you're zone-wide storage, possibly when you attach to a zone. Let's see, I don't think attach host is actually invoked at the present time. within the current framework. Some of the other interesting ones are maintaining and canceling the maintenance of storage. So if you go into maintenance mode, this will let you know. If you exit maintenance mode, if there's something you have to do in that case, you can handle that here. And also deleting the primary storage, referred to as a data store here. So if you eventually want to phase out that storage system, this method will allow you to clean up whatever remains from the storage system in CloudStack. At the very least, update the row in the cloud storage pool table to remove, I guess just reference that storage as being removed. All right, a little bit of example code for the initialize method. So what this is doing here, it takes in a map, so it's basically a key value pair. You can picture this, the data that's coming in through that map as having been passed in through the API. So there's a whole bunch of parameters that can get passed in when you create primary storage. Those parameters will end up here. And so what you want to do is collect the parameters that you're interested in. For example, what zone is it in? What's the name of the primary storage? You probably know what the plugin name is, but you can pull that out here if you want. I package it all up in this example into a primary data store parameters object. And then I just set a whole bunch of fields here that map into columns in the, I guess it would be the storage pool table. And at the very end here, there's a data store helper object, which allows me to just easily update that table with this information. Otherwise, you just have to do it more manually. All right, third phase here, the driver. So again, we got provider, lifecycle, now we're on the driver. Same kind of concept to start with. Primary data store driver interface is what we have to implement. And this is your opportunity to create and delete volumes on your storage system. So you can do that in a very dynamic fashion. And the bottom line here, we already talked about this before, but regardless of how many storage systems of the same type you have in CloudStack, you're just going to have a single driver instance that's going to be passed in the applicable information that it can act on, so it knows which of those storage systems it's creating volumes on or deleting volumes on. All right, pretty similar to what we just saw in the other two components. In this case, the primary data store driver, still it extends a data store interface, data store driver in this case. There's actually a couple methods that are specific to primary storage, taking a snapshot, reverting a snapshot. But besides that, the bulk of them are in the data store driver interface, granting, revoking access, listing the objects. So for example, all of the volumes and snapshots on the storage system, you might list them in a set of data objects. The ones that are the most interesting from my point of view are the create async and the delete async. That's your opportunity to actually create a volume and delete a volume on the storage system. Besides that, you can kind of gather from the name of the method what they do. Copy async. If you look at the method below, can copy, if that returns true for a certain situation, then copy async is fair game. They can invoke that. Resizing, if your storage system allows you to resize a particular data object, and that's your opportunity to do it. Let's move on. Pushing the wrong button. That's the mouse pointer. All right. Driver implementation. So this is just a very basic implementation here, just to kind of give you a feel for what you would do in a create async method. What I'm doing here is I'm taking the data that was passed into this method that represents the volume that I'm to create on the, in my case, on the SAN. And then I just have this create SolidFire volume method that goes off and does whatever kind of API calls we need to our particular storage system to create a volume with those characteristics. And in this case, I'm just returning an IQN to represent that volume. The next few lines are all about packaging up the information in a way that I can then easily persist it to the database. the CloudStack database. So now I've created the object on our SAN. I want to go ahead and record a row in the volumes table so that CloudStack is aware of that object. All right. Again, I pushed the wrong button. All right, API calls. So there's just a few API calls I thought I'd bring up. The top one is a completely new API call, list storage providers. And in this case, there's another parameter that you can provide primary. So even if you run this on an existing 4.2 installation with what might seem like no plugins, you'll get a single plugin back. The default implementation for storage is implemented as a plugin in 4.2 as well. So in my case, I tend to see 2 plugins returned. The second paragraph there is in reference to an API call that does exist today, but it's been augmented for this plugin framework. So creating a storage pool, we can obviously do that today. There's additional parameters like scope equaling zone, since zone level primary storage is being added in 4.2. And then, so you can see there's a URL field. Now that's not new. I just wanted to point it out because in my case, I actually have some very custom information there. This is any information that can help your plugin. So in my case, I'm passing in what we call a management virtual IP address. So I know where to talk to the SAN to create and delete volumes. And then I also pass in something like a storage virtual IP address. So when I talk to when the hypervisor wants to access the storage, it knows what IP address to talk to. And the provider field would be new. That is just saying, I'd like to create a storage pool, primary storage, that's based on this plugin. So back a few slides, we saw that the name of the plugin I had was SolidFire. This is how I note that that's the plugin that I'd like to use, the SolidFire plugin. And that final API call is actually not new. I don't think it's been modified. It's just a way of listing the storage pools. It's just kind of helpful to do it when you're using this, when you're trying to develop a plugin for CloudStack in 4.2. Let's see. All right, so what's left to do? The biggest piece we have left to do is to support root disks, compute offerings. Right now, what I'm almost done with is developing a plugin that works for disk offerings on all of the supported hypervisors. But the next thing is to work on it for compute offerings. And Edison and I have some ideas on that, but that's definitely one of the things that's on our list of things to do. The next bullet point is just sort of in reference to, we already had logic in CloudStack to create storage repositories in Xen Server, but we didn't have any logic to create, say, data stores on ESXi. So I've written code to do that. I need to get that into CloudStack in a way that's usable by other plugin developers, so they don't have to write the same code, basically. I want to make sure it's part of the framework or part of CloudStack that the plugin developer doesn't have to write by his or herself. And yeah, so then the third point is basically around sort of zone-wide storage. So zone-wide primary storage is new in 4.2. Edison and I had a discussion a couple weeks ago. We found a couple areas that need consideration as far as recognizing that you're sort of in a specific type of zone-wide situation and making sure it's handled in a way that the plugin doesn't have to worry about it. So that's some kind of framework-related activities. And then the big point at the bottom here is that this is all workable today through the API, but there's no GUI support. So if you want to add a plugin, you have to invoke the API to do it at the moment. No GUI support for that yet. And in my specific use case, where I'd like to support a particular number of min, max, and burst IOPS, I'd actually like to update the compute offerings and the data disk offerings so that they allow at least the administrator to create compute offerings and disk offerings that have particular IOPS specified. So I believe that is the end of our slideshow. Did you want to take this part?
No, you can talk about the question, but before we do the question here, you can read it, of course. But we're doing a little giveaway on the question, and so I don't know if anyone knows what it is, but there's this cool little company in Boulder where we're based that creates the Sphero ball, and it's controllable by your phone, and so they have lots of really cool apps and games, and you can putt with the ball and do all sorts of cool stuff. So that's the giveaway for the question. It's deep down in there, but it's a topic that Mike discussed, so I'll let you go for it.
All right, so I mentioned a couple times that the framework treats the default storage behavior as a plugin. Any thoughts on maybe why that might be? Worst case, I'm going to go to Edison for this one, okay?
Give everyone one chance.
I'm sorry, what was that?
To provision storage at the last minute?
To provision storage at the last minute. Let's hear what Edison has to say about that, because you have a microphone. What was your thinking on it?
I do that because I want to use the default storage as an example, so other people can look at what the storage plugin looks like.
Yeah, exactly, and you know that's a great point too, as far as like dynamically being able to do. I could think of a few reasons actually. It's great to have example code. It's also nice if you want to be able to change that default behavior. And it's probably simpler from a framework perspective if everything is just a plugin rather than having a custom situation. So yeah, thanks for that comment.
So if I can get your card, I'll...
Yeah. Let's see. I guess we're on to questions, huh?
Yep, so we should go to Q&A, I guess.
All right, there you go.
Are you going to do the snapshot provider as well?
Oh,
Are you going to implement the snapshot provider as well?
That take snapshot, revert snapshot? So that's an interesting question. We, at SolidFire, we have a cloning ability at the moment. And actually, as McLean mentioned, my full-time job is to work on CloudStack, but not just for SolidFire. I want to do general purpose CloudStack development. And so, yeah, I think as we not for this first release, I don't think, but I believe we would have a very good use case to do snapshotting. Yeah.
Can we do provisioned IOPS like AWS with SolidFire?
Yes.
Right. Yeah.
So the way SolidFire works is when you carve out a volume, you're able to set the minimum, maximum, and burstable IOPS to that volume. So if you associate one disk to that volume, we will guarantee the minimum level, and then of course maximum, it would be a cap. And then there's a credit type of system to allow you, think of like boot storms or other opportunities where you'd want to, for a very short period of time, allow people to go beyond the max. Those are all definable and all API driven on the system.
All right, so one of the things I was kind of thinking about, I know with creating the size of a volume, a lot of times we specify it's a X gigabyte volume, and then the user picks that. Now there's also a customizable option as well where they can pick the size of the volume. So I could see it going both ways as well with the IOPS, where either the administrator just sets it and this is what you get, or possibly a customized version of that. Next question. Well, maybe Karen has a question in the back. Yeah? All right, thanks guys.
Thank you very much.